Hello everyone, welcome all to Physics with H-Notex. So in this video we will discuss about the first chapter Verma question, and here we will discuss about the objective part 2. So let's begin, and here's our first question, that is the dimensions m l minus 1 t minus 2 may correspond to, and here is our options: work done by force, linear momentum, pressure, energy per unit volume. So let's check. So for work done, we know the formula is F dot S, that is force into displacement, and we know the dimension for force, that is m L1 t minus 2, and for displacement this is L. So here the work done will be m L2 t minus 2. Then linear momentum, and we know the formula for linear momentum, that is m into v, mass into velocity, and this will be m L1 t minus 1. uh, this m is for mass and this L1 t minus 1 is for velocity. Then pressure, we know that pressure is force per unit area, and force is equal to m L1 t minus 2, and for area the dimension is L2. So here the pressure will be m L minus 1 t minus 2. So this matched this dimension, so here pressure will be our first answer. Then let's check the last one, that is energy per unit volume, and we know the energy, that is kinetic energy half mv square, and volume is volume, so energy by volume, and we know the dimensional formula for energy, that is m L2 t minus 2, and for volume this is L3. So here the energy for unit volume will be m L minus 1 t minus 2. So here we have two answers, that is pressure and energy per unit volume. Then the question 2 says choose the correct statement, and here is our first option, that is a dimensionally correct equation may be correct. Second is a dimensionally correct equation may be incorrect. Third, a dimensionally incorrect equation may be correct, and option D is a dimensionally incorrect equation may be incorrect. So we can confirm these two options, that is a dimensionally correct equation may be correct is the right one, and option D, that is a dimensionally incorrect equation may be incorrect, this is perfectly fine, and this is our right answer. So let's check the option B and option C, that is a dimensionally correct equation may be incorrect, and option C says a dimensionally incorrect equation may be correct. So option C is totally wrong, and let's check that option B, that is a dimensionally correct equation may be incorrect. So let take an example, that is v square minus u square is equal to 2as, and here v stands for final velocity, u is for initial, and 2 is a numerical value, a is the acceleration, and s is the distance or displacement. So we know the dimension for velocity, that is length by time, and because here it is v square, so the dimension will be L2 t minus 2. Similarly, the dimension of u square will be L2 t minus 2, and the dimension for 2as, that is 2 is the numerical value which has no dimension, and a is the acceleration, that is length per time square, and s is the displacement, that is into length. So here the dimension of 2as will be L2 t minus 2. Because we know that the numerical value have no dimension, so we can write the equation as b square minus u square is equal to as also, which is dimensionally correct, but the equation is incorrect. So here the option B is also the right answer, that is a dimensionally correct equation may be incorrect. Then choose the correct statements, and here option A says a quantities may be represented dimensionally in terms of the base quantities. Yes, this is the true one. A base quantity cannot be represented dimensionally in terms of the rest of the base quantities. Because if we take the power 0, then we can't represent it. So option B is also true. Then the dimension of a base quantity in other base quantity is always 0. Yes, this is also the right one. Then option D says the dimension of a derived quantity is never 0 in any base quantity. And this is the wrong statement. So here option A, option B, and option C are the right statements. I hope you all enjoyed the session. So for more videos, please do like, share, and subscribe. Thank you.